Okay, what exactly are stationary points? I can tell you, you have learned stationary points, just that you do not know it's called a stationary point. I give you a few examples. What do you use to call this? Turning point. What other thing? Minimum point. Similarly. What do you call this? Turning point. If not, you can call it a maximum point. Okay, what's the commonality about these 2 points? The most extreme value? No. Okay, it lies on the line of symmetry. Very good, Melissa. Actually, remember what you did for curve sketching. Other than that? Yes, I heard something. Which end? The gradient will always be equal to 0. Why we want to talk about the gradient? We are talking about the whole topic about dy dx. Obviously, I want to talk about the gradient. The gradient of your minimum as well as maximum, or in other words, can be summarized as the turning point, will always be equal to 0. So you have your minimum point, you have your maximum point, and all these are actually what we call stationary points. So you have maximum point, you have minimum point, you can call it turning point. Now, there's one more type which you all haven't learned, which I'm going to introduce today. This is the last kind. Okay, there are times where you have this kind of curve. You don't learn it in E-Maths, you learn it in A-Maths. Okay, I'm going to show you tomorrow. Now, can you see that this is increasing? Then suddenly it becomes flat. It increases again. Alright, so there is a certain point over here where your gradient will also be equal to 0. Do you agree with me? Similarly, this is decreasing. Suddenly becomes slightly flat, then it decreases again. Similarly, there must be a certain point over here where the gradient is equal to 0. And there is a special name for these 2 particular points. Why is there a special name? Take a look, it's different from these 2. Why is this called minimum and this called maximum? What do you notice about this particular gradient here? Gradient is negative. Then it hits 0, it increases. Similarly, gradient is positive, increasing function. It hits 0, suddenly it becomes a decreasing function. But this 2 is forever increasing over here. It's always increasing function except at this particular point. After that, it increases again. Similarly, this particular curve is always decreasing except at this particular point, and after that, it decreases again. And let me tell you, this is what we call a point of inflection. Not reflection, don't spell wrongly. Point of inflection. So far, so good? In other words, actually the most important thing I need to tell you is, at stationary point, what is our conclusion? What is common about all these stationary points? All the gradient is equal to 0. That's all. We are done. All the gradient of these stationary points will always be equal to 0. Regardless, it's a maximum point, it's a minimum point, it's a turning point, or a point of inflection. Their gradient will always be equal to 0. So basically, the word problem will just require you to find the coordinates of all these stationary points. Okay? So far, so good? Good. Please copy this down first, if you need to.